presentation, and also during the presentation, I would be happy to also kind of make it conversational in case you want to add anything. So Prashant, you yourself, you are a long time industry veteran. So I would also love to hear from you in between. So please feel free to add. You have a lot of tremendous insights
Sure.
in the field of cybersecurity, right? So please feel free.
Right.
Huh? So
Sure.
and also for the audience, thank you for joining today. Please share your thoughts, your questions, and generally the challenge which we have for this online format is we can't really make it very conversational because sometimes there are audio issues, etc. But towards the end, at least, not just your questions, in case you want to also speak about some comments of yours, let's do that. It'll be great to make it as conversational as possible, given all these constraints. So are you able to see the screen? I guess
Yes.
so, right? Perfect. So I will skip my introduction. I think Prashant did a great job. Thanks, Prashant, for that. So let's come to the topic of today. And before we get into the topic, let's discuss a little bit about some of the industry challenges which I have noticed. And Prashant, I would also encourage you to share anything in case you want. So a few of the top industry challenges which we kind of noticed is, unlike say 5-10 years back when anything that had to go online, that could only go online through the IT team. But today, all the projects team, marketing team, sales team, cloud team, they are empowered to create their own IT asset. They can launch a new application, and that has kind of created a tremendous rise in shadow IT and incomplete asset inventory. So this is a challenge which is a kind of unsolved challenge as of today. And this kind of shadow IT could be something which is online, could be something internal inside the network. There are two types of broadly shadow IT kind of IT assets which you own as an organization, but you are not aware of. And the second type could be which you use as an organization, but don't own it, and is not known to the security organization. So the first type of shadow IT, which is the assets that you own but you don't know of, needs a very different approach to be kind of identified. The second type of shadow IT, where your team is using certain cloud or assets, but your team is not aware of, that kind of shadow IT is dealt in a completely different way. The second one is done through more CASB kind of solution. The first one is handled through attack surface management kind of solution. And then the internal asset inventory, there's a new kind of solution which are emerging. So just to solve the asset inventory problem, there are three different types of technologies, and very non-overlapping, completely different type of technology. So this is one of the big challenge, because if you don't identify your assets, then obviously you can't put the controls. Then organizations, another big challenge is organizations typically test their crown jewels a few times a year, or maybe if the organization is very mature, they might even do weekly, etc. But whatever that frequency is, people test some of the assets some of the time, whereas the hackers are trying to attack all of the assets all of the time. So for a hacker, they just need a 1 hour window of a specific vulnerability or open port, and they can get into. But as a defender, you need to make sure you are always safe, right? Which is almost impossible. So it's a kind of unfair battle, but then that's how life is or reality is. Then these multi-stage attacks are actually becoming more prevalent these days, like one of the top banks in US which got compromised. It happened because of a series of multi-stage attacks. One of the major recent compromises which happened for a very well-known company happened because of a very complex multi-stage attack. And this kind of multi-stage attack where the hacker first exploits X and then from there moves to Y and then from there to Z, this kind of attacks simulating that is very, very hard. It's very, very hard to scale or figure out those. Then the other is misconfiguration. So this is something very simple, like open MongoDB without any password. It sounds very simple, but then Amex had exactly that situation. Now, obviously, Amex is a great company and they have the best of the tools and teams in place. There's no doubt regarding that. But the reason why even such a large and such great organizations sometimes get compromised because of such simple stuff is because they were not aware of that particular asset that was made online, most likely by their marketing subcontractor. So misconfigurations in the unknown assets is very common and is causing a huge number of breaches. And also the other thing is when it comes to security testing, considering that our today's focus is more on testing and offensive attack simulation. I'm not talking about all the other type of challenges which the industry is facing. It's more around the testing side. So our industry had been testing for like 2 decades, right? And the classical way of testing had been generally like generate a report and give it. So you have various scanners throwing these reports or consultants giving you reports. And I believe the industry needs moving away from report to alerts, just like what happened to the SOC. In case of SOC, if you remember 5-10 years back, SOC used to give reports, and quite some time back, these reports used to come once a week. But from that, today, it's all about real-time alerts when it comes to security operations center. So security testing also has to move to that direction or has to reach there, where we are able to continuously test and continuously generate those kind of alerts. So moving from report to alert based kind of model. So these are some of the key challenges. Um, so before we move to the other part, I wanted to share some of the interesting statistics. So at FireCompass, we monitored the entire global deep, dark, and surface web, and also we do this continuous attack emulation or red teaming on our customers organization. So based on this data point, which is very huge, we have one of the probably most I mean one of the richest kind of database of the kind of vulnerabilities and risks at a global level. So with that data, there are some very interesting insights which we got, so I'll share some of those. So mm, we noticed, so this is a few months back when we first came up with this report, but even today the situation is somewhat similar. So there are more than 500,000 open databases which are out there, which includes MySQL, Mongo, etc., etc. So here are these databases which doesn't have any password and people can simply get into, and that number is 500,000. So that's pretty scary. So so 15% of the cases we have seen that internal employees leak credentials, sensitive keys, etc. are there in the code base, exposed code base. So we have seen that CI/CD tools like Jenkins, etc. This is one of the major source for um, code leaks. So these are some of the common DevOps tools where such kind of exposures are common, like SonarQube, Docker. These two kind of forms the big part of the pie. Jenkins come next. This humongous number of open cloud buckets, more than 10,000 public Elastic Block stores, then 400 plus public uh, RDS. Now, these numbers are actually far more. So this is like part of a snapshot, which part of a sample which we analyzed around a few months back. So more than 700,000 public AMIs from 200,000 accounts. These are all which are exposed, not secure properly. And around 500 million AWS buckets are there, which are open. Now, not all AWS open buckets are risky, but a percentage of that actually has got internal customer data or some other confidential stuff. A lot of times these AWS buckets might just have normal benevolent images, but a small percentage also has got critical data. So more than 500 million open AWS buckets. We also found that 30% of the organizations have open LDAP or RDP or SMB, and you know that many of these are being exploited by the malware. 80% of large organizations have multiple exposed UAT servers. So UAT or pre-production systems actually can become a very big risk. And the reason is that in a lot of cases, it's very, very frequent that the development team, the developers would put production data in pre-production systems. It's very common where they have even production keys in pre-production systems, and these pre-production systems are rarely tested, right? So hackers very frequently try to find out this pre-production system, attack those, and steal production data. Leaked passwords, more than 6.7 billion leaked passwords were there. And so now let's look at the offensive security landscape. So obviously, if we have to secure ourselves, we need to do what the adversary is doing. So the idea is that you should hack yourself before others do. Now, when you look into this red teaming landscape or doing this offensive attack simulation, and if you want to kind of break down this space into a few buckets so that you get the holistic picture. So we took this from Gartner. So you can have in one axis simulated attack versus real world attacks. That's the x-axis. And continuous testing versus point-in-time testing. So what you can see is that point-in-time real-world assessment includes the usual red teaming consulting services, the bug bounty programs. Then simulated assessments could be things like cyber ranges, breach and attack simulation. And red teaming, the continuous automated red teaming is emerging in this space where it is continuous real world attacks. So a lot of organizations are gradually moving towards this. The basic premise is if hackers are trying to hack all of your assets all of the time, you should also do the same. So continuous discovery and continuous testing. Similarly, if you look at the blue team landscape, you can have the internal and external assets in x-axis and more depth versus more breadth in the y-axis. So you have a set of tools like the VA tools and the digital risk protection tools, which looks at the external assets. The vulnerability assessment could be both for internal and external assets. And when you look for the new kind of things which is coming up, the attack surface management tools, which discovers all your external assets and gives extraordinary breadth, but it does not go deep. I mean, the attack surface management teams or tools, attack surface management tools will not try to break in. They will try to discover. So they have the breadth and only for the external assets. So this is the blue team landscape. Then for the internal asset discovery, there are asset management tools, and not the old school asset management tools, but there are this new type of asset management and rather asset discovery tools which are coming up. So these are the two red teaming and blue teaming landscape. And if you look at the depth versus breadth, the cart, if you do continuous automated red teaming and attack surface management together, then it combines the breadth and depth together, because ASM gives you the breadth of discovery of your attack surface, digital attack surface, and red teaming also does the attack and gives you the depth. So cart plus ASM gives you the depth and breadth. You can also do the attack simulation using breach and attack simulation tools. That works more in the context of the internal network. So what are some of the key trends in the offensive security landscape? So I mentioned at a high level about the attack surface management tools. So these are the internet-wide monitoring tools. So there are these setup tools which has come up, which goes and indexes the deep web, the dark web, the surface web, and does it on a continuous basis. And absolutely from zero knowledge, it is going to go and build your asset inventory and help you to do better vulnerability management, help you to do better shadow IT discovery, help you to build better asset inventory. So these are the three key use cases for ASM. For continuous automated red teaming, very quickly, normal penetration testing or vulnerability assessment is where you are given a specific target and the tool is supposed to find out the vulnerabilities or risks, or the consulting organization or your own team. So you know the target and you try to find out the risk. Sometimes you are also given the partial access to the application, etc., etc. Whereas in case of red teaming, you are not given any target. Red teaming doesn't have target, but red teaming has objective. So instead of giving a target, you are given an objective that break into my organization in whatever way you can, or steal my data in whatever way you can. So pen testing is where it is target based, whereas in red teaming it is objective based. And when you have an objective, broad objective like that, or even a narrow objective, whatever be the objective, you're not given any asset list, nothing. So as a part of red teaming, you have to first go and discover all the assets, do reconnaissance, and then go and find out the vulnerabilities, and then possibly exploit one of the system, and then do lateral movement, then do data exfiltration, etc. So red teaming is the end-to-end process of the complete discovery to testing to exploitation, etc. So continuous automated red teaming is the software-based approach. Largely, these are software as a service-based approach, which does the same to various degrees. There are certain things which card tools can't do, like the physical attacks and the wireless attacks, etc. As of today, card tools don't do. But card tools predominantly focuses on doing continuous reconnaissance and continuous attacks. And key use cases are vulnerability risk management, security control validation, discovering your ransomware attack surface, nation state actor and other adversary simulation. So if you want to know how secure are you from the perspective of a nation state actor, the best way to know it is by simulating such kind of attacks. So you can do it through consulting team, but that's point in time. The continuous automated red teaming allows you to do it on a continuous basis. The best approach is that you sometimes do manual, but continuously do automated, because manual red teaming has certain advantages. So I'm a believer that it's the combination of AI or automation and humans which gives you the best result. So more like the approach of um, Iron Man. So it's machine and man together, both. So purple teaming is the other thing which is gradually getting more adopted. The idea is that the red teams and blue teams collaboratively work together and share the insights amongst each other so that you can have richer findings, you can have better collaboration. And I mentioned about hybrid is what I believe in personally, because there will always be a few things which man will do better than machine, and machines will always do certain things better than man, especially when you need to do something in a repeated manner. So humans are not good in just doing things on a continuous basis, and of course we don't have enough humans in the world to do that. So combining man and machine effectively is the best way to go. So that's broadly about the key things which I wanted to talk about, and very short, quickly, mm, about FireCompass. So we are into CART, or continuous automated red teaming. We continuously monitor the deep web, dark web, surface web. We have indexed the global internet for last couple of years, and we have stored it in our big data platform. And then it's a complete SaaS-based platform. You don't need any hardware, no software, no agents, and the system will automatically go and discover your attack surface without any need for any information. So it's absolute zero knowledge. Go and discover your domains, subdomains, open database servers, cloud buckets, code leaks, leaked passwords, pre-production systems, etc. And then continuously launch attacks, all kinds of attacks, including network attacks, DAST attacks on applications, DAST, SAST, IAST on mobile apps, social engineering attacks, and multi-stage attack, and then provide continuous alerts. So that's broadly how FireCompass works. So I'll keep this part very short. So broadly, this is what I wanted to share about. So anything that you want to add, Prashant, from your side, and then we could also go to some of the questions.
Nothing, because you've covered it well. In fact, the point where you say, it is continuous attack management, how is it different from just monitoring? I think that people would, audience would like to know.
Okay, so that's a great question. So let's do one thing. Let us, if suppose you want to break down your security architecture into a few buckets. So NIST framework is probably the one that does the most intuitive way of bucketing. It's something which is very business friendly for even the board, CEO, management to understand. So if you use NIST CSF, so the first part is identifying or identification of your risks, assets, threats, then protecting, then detecting, then responding and recovering from a breach. Now, if you look at these 5 buckets, the monitoring typically is in the detection bucket. And the idea is that if an attacker is trying to break into, you want to detect that guy, detect that bad guy, that here is a bad guy trying to attack my organization from this IP address. Or if somebody has already compromised you, you should have the ability to detect it. So the monitoring, typically using SOC, people consider this as that function where you are detecting attempts to break into, detecting an attack happening, or detecting a successful attack. Whereas what we do is not in the detection bucket. What we do is in the identification bucket, or what card does is the identification, where it goes and identifies that here are your open database servers, and here is an application which is a pre-production system, and the production keys can be accessed because this application has a vulnerability. So detecting your detecting hacking attempts is taken care of by SOC and the monitoring folks, whereas the identification of your assets, identification of the risk, and identification of the vulnerabilities is done by CART. It can also be done by vulnerability management. It can be done by red teaming. Now, the interesting thing is that CART and monitoring can work very closely together. Like, for example, if these feeds are passed on to the SOC, and the SOC then gets this data point that here is open RDP server, and this has a known vulnerability, then any packet coming to that or any attempt on that machine could be put on high alert. So monitoring and CART can go very synergistically together. So that's broadly kind of how it works. So Prashant, does this answer your question?
Yes, it does. Thank you. Thank you.
Great. So are there any questions from anybody? If any of you want to just post any question, please put it in these questions or chat, and we'll try to, or also if you have some comments. So one of the questions is on like a cart has like does it throw false positives? So that's a great question. Yes, cart can throw false positives, and it's not just cart. Vulnerability assessment tools, or as a matter of fact, any tool can throw some false positives. But if you tune the product well, and also if you add a layer of human intervention on top of it, you can eliminate those false positives or reduce them drastically. At FireCompass, we have a managed services option as well, where we can take care of that. So that's a way to handle. But those who have their own teams in place, they can also do it by themselves. So typically, any tool will have false positive. We do continuous research to minimize that. But if somebody takes managed service, then we can assure that we'll remove those false positives. And also, I can see a follow-on question on that, on what about false negatives? And by the way, if anybody else has any question, please do uh, post it in the questions tab. So false negatives are vulnerabilities which are missed out, or there are risks which the tool is not able to identify. So false negatives can also be there with any tool. Theoretically, you can't have zero false negatives. I mean, for any computer science problem, if you just get into the basics of computer science, you will see that achieving that is impossible unless we solve the Turing problem kind of thing. So there can be false negatives, and that's the reason why 0 days get discovered. People find out things which the world did not know before. So those kind of things can happen. Our goal is to make sure that you can discover all the things which are known to the world. Like for example, covering all the CVEs which are there, covering all the classes of WASP for web application. So taking any of these well-known framework and having as complete coverage as possible. If you're doing red teaming, look at MITRE framework. That gives you a good framework for coverage. So for such kind of coverage, using CVEs and making sure that all the CVEs are covered using OWASP and MITRE framework, that's the way to go. Automated tools, like any automated tool based approach, can only work if there are certain indicators. Like for example, if you have an asset which is out there online and a database which does not have any keyword related to your organization name, then the tool can miss that. But if suppose there is a keyword in that which is related to the organization but is not very apparent, and if you add that keyword, then it can detect that. So it also depends on how well you kind of configure this tool and also in the context of it. So sometimes it may happen that vulnerabilities can get missed out. So we suggest a combination of both manual and automated as an approach for the best breadth and depth. So there is another question which is on how to assess if an organization is ready for CART. So that's a great question, and I actually love that question. I actually believe that everybody should not have CART. I mean, of course, that's not good for us because everybody using solution like us is good for us. But then, if I think from the organization perspective, it's not necessary that everybody should do continuous testing. Then what should you do? So such kind of decisions is to be made very judiciously, right? So if you have X amount of budget and bandwidth, you need to deploy that in identify, protect, detect, respond, recover, all the 5 buckets. It can't be like I do continuous testing but I don't have a good response and recovery program. And response and recovery program is very, very critical. So the first thing is like looking into your budgetary allocation and see whether you can create a budget for that or not. Now, I'm a strong believer that if you don't do this complete attack surface discovery and don't do the testing, then one of the legs of your table is missing. So I believe that you must do your attack surface discovery and testing. Now the question is, should you do continuous or not? So this is how I would probably attempt if I was part of a organization, and I need to secure. I would first look at what frequency, if I test, I should be able to fix it. So that's one of the things which I will look into. So I would probably start with like maybe doing monthly assessment, at least monthly complete attack surface discovery and testing. If the budget permits, it's always good to do continuous, because in that case, the critical ones I'll get to know immediately. But even if you can't do continuous, it's a good idea to do it frequently. And even if you can't use a tool to do that, in fact, tools are gradually getting much cheaper. So in a way, tools are better alternative than consultants. But sometime back, consultants were the only option. You could only do red teaming using consultants or your internal team. So at least doing it in some way, whether using your internal team who can get a few of these open source tools together. So there are a lot of open source tools which are out there available. So if you have a person who knows how to use that, at least doing to some degree where you do reconnaissance and do those attack simulations, etc., is a good first step. The second step will be doing frequent or regular red teaming. That's the level 2. And the level 3 maturity is where you do continuous automated red teaming. So I would probably progress it in 3 steps. And depending on the criticality of your organization, you may just go to level 3 in one go also. So that's a contextual decision which one needs to make. But if you want to progress step by step, these are the 3 steps. Great. So I guess these were the 3 questions which I could see. Um,
I have a
Prashant,
question
do you
because
want to add anything? Yes, Prashant.
yeah. When we do this, do we also, find vulnerabilities in the web applications that the customers are using? Let's say a customer has 30 web applications, and out of these 30, 10 are being accessed by their customers, and remaining 20 are being accessed by their internal users, their employees, and all are exposed on the web. Uh,
Yes.
do we give them a report which shows all the vulnerabilities of those web applications?
Yeah. So the idea is to do complete attack surface testing, which includes all the web applications. And there could be a lot of very interesting attack vectors. And I'll give you one example of a real situation. In case of a financial services organization, one of the internal applications was accidentally natted online. And also there were certain few hundred leaked passwords in the dark web. So the system tried out those passwords on that internal application which was accidentally natted online, and our system got partial privilege, just a normal user level privilege. No data was there. And then using that partial privilege, the system then started doing the dynamic application security testing. And using that, it discovered directory traversal vulnerability. And in one of the directories, it discovered base 64 encoded logs. It was then decoded, and then a static analysis was done on that, and we found out the admin keys. And using that, we could get the complete database of their customers. Now look at this. This is a complex multi-stage attack, right? You need dark web data, you need attack surface discovery or reconnaissance tool, then you also need application testing tool, then you need a decoder, then you need a static application security testing tool. You need like 5 tools which needs to work in a specific sequence. So to answer your question, Prashant, yes, the platform does cover application security testing, but it goes far beyond. In a usual application security testing, you can't do this because the application security testing guys don't have access to dark web data, or generally they don't do that. So we do the application security testing, but we also have bigger breadth because of the nature of testing which we do.
Right. So it will be if they just go with a basic scanner for their applications, it would be just the report of that web application. Whereas in FireCompass's case, it would be all the related information with that web application, not just the
That's it.
vulnerability.
Yeah. So one is a normal scanner will not be able to identify or find out targets, right? So you have
Yeah.
to feed a target application, like this is my application domain, and give the scanner the job to test it. Or you have to give the IP address and tell the scanner to scan it. Whereas in case of cart, you don't need to give any target IP address or target application. So the cart platform goes and goes and automatically discovers your attack surface. So that's one difference. The second difference is that cart platform can also find all those associated information which you just mentioned and correlate those and do multi-stage attacks.
Right. Right. Thank you, Bikash.
Great. So that's wonderful then, huh? Thanks, everybody. Thanks for the questions. And in case you have any other questions, please do send it to us. We will try to answer those offline.
Thank you, everyone. Thanks for having being here. And as Vikash said, if you have any questions, you can send an email to us, and we will have it replied. Thank you.
Bye. Thank you, everyone.